All right, so I have a little bit of a break before my next meeting. And this is such a great question. So piecewise functions, I mean, this quiz, you're going to talk about absolute values, you're going to talk about piecewise, you're going to talk about step functions. So it's a lot of different ideas all rolled into one assessment, trying to see, did you get it? Did you not? It's okay either way. And then sometimes you get it, but it's just the technology. So some lucky student I'm impersonating, I know who they are. Okay. This right here is going to be my help video for both ideas and how to graph. So I'm going to go kind of quick. I'm not going to do a whole lot of my normal rambling, and you might be like, this is the best video yet. Inside, by the variable, inside the concept of the function rule, you keep hearing them talk the function rule. Well, the function rule for us is the absolute value. So inside it's going to spit it out positive. So we get that V graph. If there's a negative on the outside, then it would be a reflection down. It'd be pointed down. Okay. That inside right there by the x, that is a horizontal shift left or right. But we do the opposite. So if it is -3, we go to +3. And then on the outside, it's a vertical translation. So if it's +1, that's direct. We just go up 1. If it's -3, we go down 3. The other thing about absolute values in this form, this gives you the vertex. +3 is the x coordinate. Up 1, +1 is the y coordinate. So we're looking for +3 up 1. Oh, not this one because it's not, well, it's not negative anyway. And it's also reflected. Aha, +3 up 1 facing upward. We're good. We're going to click that one. We're going to move on. Here's our graphing tool. Oh, first plot the endpoint of the ray, then plot any point on the ray. Okay, so say you've got this, you don't know. The other one I just talked about how to read it, how to read the standard graph, which would have been this one. Watch, I'll show you. This is the standard. This is not ours. So if we click the vertex, click a point for the ray, click the vertex, click a point for the ray. That is this standard absolute value equation. So this says we're actually going to go left 2. 1, 2. Whoa, that didn't work. Let's take this 1, 2. What in the world is happening here? 1, 2. There we go. We had to move all of the points left 2. Okay. But then, here's this reflection. So we're going to reflect across the x-axis. So we reflect down. Okay. We reflect down. Let me reset this. Let me go to Desmos. It's important to be able to do this. Here's Desmos. Desmos. Oh man, a student, we looked this up and I can't remember. I already forgot what it means. It's okay. All right, let me hide this. Let me get rid of this. Let me move this. Absolute value right there. Click it. X plus 2. See how it shifted over? But we have that negative out front. There it is, shifted down. You're like, well, what about this line? I don't know if it matters. There, I hit space. I hit space and it popped up. All right. Now, if this, you need to click this beginning, the end point of the ray, and then another point on the ray. So I would just look, here's -4, -2. So on my other graph, I might hit -4, -2. Then over here, it looks like 0, -2. So if I came back using Desmos to help me, I know my ray, my end point, is at -2. And then I think I said 4, -2? Yes. Click here again. You got to click the center again and then click over here. There you go. Okay, we're going to keep going because we have another couple to graph. So, 9 minutes. We can do it. All right. Something to notice here. There's no x in this piecewise function. Do you see that? That just says 3. F of x equals 3 for x less than or equal to 1. That means we're going to have a horizontal line at y equals +3. So we can already, okay, they all have a horizontal line at y equals, right? At y equals 3. That's because every value of x, y will equal 3. It's a constant function. Okay, let's look at this next thing. Oh, we talked about this in class. We talk about this often. There's an equal to sign underneath it. You see that? It's going to be a closed circle. So that really helps us. That means it's either this one, see a closed circle for this piece of the function, this piecewise function, this piece. Closed circle, that's out. Okay. All right, so now we just have to decide between these two. Well, according to this one, the next piece of the function should be f of x equal to 1 for x greater than, strictly greater than, the open circle 1. So if our function, the next piece, is another constant function, another horizontal line, because every value of x, the output will be y, no matter where we are. It's not. Ooh, it's x. It's x. So we know it's a line. And in fact, it's the line y equals x, the line that goes up 1 over 1, up 1 over 1, and through the origin. Okay, so that's this one. See this line right here? The line f of x equals x, that means for the input, the output is the same. So if x is 1, y is 1. If x is 2, y is 2. If x is 3, y is 3. Only because it's a piecewise function, and we put a domain restriction on that part, the input, we're going to start at values strictly greater than 1, meaning at 1, our piecewise function actually equals 3. But at 1.1, our piecewise function equals 1.1. Okay? At 0, it equals 3. At negative, x equals negative 1, 3, 3, 3, 3, 3 for all those values. Less than x, less than or equal to 1. Okay? So that's this part. That's what you're looking for, those key features. You're looking for, is it a constant? Be careful, which open circle? Which one has it? Which piece of the function has the closed circle? Maybe both. On our next one, here we go. 6 minutes. Okay. Let's graph it because it'll help us, right? It'll help us. So Desmos is not great at letting me copy paste this. So I'm going to go type -2 and now x greater than 3. Maybe I will. Let me just take just this portion. Let's see. Control copy. Control V. I can't use that comma. I know. A meeting alert. Shift. Is that fine? Oh, okay. So something happened. It didn't understand the symbols. Okay, it doesn't understand this symbol. So that's all right. Come down here and replace it. Where are you? Oh, there it is. See? I'm like, where is it? It didn't show up. But this red line says it's fine. Reading technology, thinking about technology, troubleshooting, right? If your phone is not working, you will figure out how to make your phone work. Same thing applies here at school, okay? When your technology isn't working, take some time, take some grit, and be like, I'm going to figure this out. Okay. All right, so there it is right there. That's that piece of the function. I'm going to come down here and go back. -1/3 x minus 5 for x less than 3. -1/3. I have to arrow over so the x isn't down here, right? That's not right. Arrow over x minus 5. I'm going to copy this. I'm lazy. And then I'm going to switch this, highlight it, and come down here and switch. Ooh, that's cool. Look at that. Zoom in if you want to. Change the way it looks up here. Let's do it. Cool. They both meet there, and we created our own little piecewise graph, kind of like a sideways absolute value, but we can't really do that with an absolute value, so we made a piecewise function to represent whatever this represents. In real life, it might represent something. Right now, we're just learning the definitions, what it looks like, how it works, how can we model a situation that maybe a regular function doesn't work for. Well, can we break it up into pieces and change it when we hit a certain point? Sure. Okay. Right? Like we're slowly going down until we hit this point, and then whoo, it's a lot steeper drop off. Like once we get to 3, we're going to start declining real fast. So anyway, there it is. So now we go back here. What in the world are we going to do? We're going to click our array. We're going to use Desmos to help us figure out where. Okay, I'm going to start here at 3, -6. Let's do it. 3, -6. There we go. Okay. Now, depending on where you're going to go first, you're going to click down here or click over here. Well, over here is kind of easier, so I'm going to go click 0, -5. Get that right, 0, -5. Boop. Okay, cool. Well, can I click like just randomly something to kind of make it look like it? No, I need to be pretty precise. So let's go back to Desmos. Let's try to find something that's nice. 3.5, -7. So now I'm just kind of sliding. I'm looking for where it hits. See these little marks? Ooh, that might be good. No, it's not. It's like 3.2. What about down here? What's this one? That looks like 4, -8. Right? It's not quite. Let me go up. And if ever you're, there it is. So I'm sliding. Hey, 4, -8 is on that red line. Up here is, let me zoom out. 4. Oh, there you go. That might be better. -8. So I'm going to go click. But first, we click here again. Then we go down and we click 4, negative. Is that it? 4, -8. I wish it would highlight for you, like tell you the value so you can check because my eyes, man. Whoop. Okay, we did it. That should be fine. Let me do it one more time. Reset. Once you figure out your points, Ray, you need to click at your endpoint, which was 3, -6. Then this side of the ray went through this point. Boop, it'll make it for us. Then I click here again. And then it was 4, -8. And that's that other point. I'll just double check because this is a student's. Yep. Okay, here we go. Ooh, our step function. So we did this in class. But see how it doesn't really help you? These graphs to me are so similar because of the steps and the circles and the lines. They get easily mixed up. So I want to use other skills, other things that I associate with. Okay, I got to finish this now. So here we go. Here's the interval. It is the floor function. Oh, what are my notes? Floor function. Ugh. I'm going to go over here because I have to look it up, guys. I really do. Floor x, x -2. Cool. All right, that's helping me. The interval, -3 x, the +3. Okay, but that should be the floor because see it's on the bottom. Negative -2. So look, it's through -2. The solid dot is on -2. Boom. Let's go see if that helps us. The solid dot is on -2. I like that one. It's the only one. There you go. You found that key feature. We used a tool to help us. I couldn't remember which side the dot was on, and I don't have my notes right now. I don't have my notes in front of me, and I have to go. But I just thank you for taking the time to watch this. It was very quick. Maybe you like it better like this. Just quicker, straight to the point, not off on tangents. Let me know. Thanks for watching. Thanks for asking these questions. Keep them coming. I love thinking about them, answering them, and how would I solve? How would you solve? If you solve in different ways, share with me, share with your friends. Right? There shouldn't be a circle here. Is there? See, look. What? How come if I'm at y equals -3 right now? You see that? But it jumps up because it's an open circle there. So for this floor function, and again, it's the floor function because those lines are at the bottom. Well, let's hit submit. Well, let's hold on. Before you trust me, I don't have the answer key right now. And I have to go. Okay. All right. You don't need an answer key when you're willing to take your time and think about it, when you're willing to check your work and trust what you understand. Okay? So thanks again. You guys are awesome. I hope this helped. And I have help labs, emails, Teams, texts, phone call, live class. Just keep up the great thinking and great questions.